Thank you for your patience. Continuing our review, we had a request for 22.2.4 part D as well. Mechanism towards the formation of this bisphenol A. It's been a molecule that's been in the news for on and off for more than a decade. It's used during the making of certain plastics. It softens the plastics, but it also ends up leaching into the environment and ending up in your baby's mouth when she chews her rubber ducky. And there's some hormonal implications involved that we're pretty sure are conducive to bisphenol A not being good for that practical use. Anyway, enough talk about that. We need to do a reaction we've never seen before, but obviously we're putting groups on this phenol. All right, we're putting a group on this phenol. And it's going para, as we would suspect is the major product. We somehow have to make this carbon here into an electrophile. That's this carbon here, isn't it? And I think that's where water is going to be lost from them eventually. Well, how do we activate carbonyls? We've been doing that a lot. We protonate them. And HCl is definitely a candidate for that. And red first. After it's activated, you can attack it using the benzene. Use the electrons that go towards the pi carbon. So you've activated it, and then you attack it, and it gets neutralized that way. We're going to generate this species here. We've got a phenol. Phenol no longer. It's lost its aromaticity. Now, you could have used the lone pair on oxygen to show that the oxygen is the activator, but you don't have to. You can just do the direct para mechanism. And our new group is a dimethyl hydroxyl group. We have a cation there. And we have the conjugate base of HCl here. That anion is way out of position. And, whoa, the H is downstairs. And resonate up. And we've generated phenol with an acetone attached. Phenol with an acetone. Maybe that's where the A comes from, because it came from acetone. Just thinking out loud here. Now somehow we have to make that same carbon into an electrophile. And I think this is the exact one we did on our previous example. If I can make that into a cation, I can make this happen. And I can indeed do so when I have HCl present, which I just made again. First step, protonate it. This time the role of protonation is activation in a sense, activation towards making it a better leaving group, right? And that's exactly what it's going to do. It's going to leave. Generating a nice tertiary benzylic carbocation. Should be plus facile, as they say. That's French for very easy. And here's what it's going to look like. We have OH here. We have a cation. Do you remember back in 241, we predicted this cation to be as stable as a, let's see, tertiary plus 1.5 for being benzylic, 4.5 degree carbocation. Yep, that's how easy it was to make. And this is where we have to use our second molecule of phenol as the nucleophile here. So find a place to draw your next phenol. And it's going to go ortho as well, or para as well. Para to the OH is the group, para to the OH is the group, both times. It's the only para pi electrons I drew. And we're going to generate this intermediate here. It's got the original phenol over here on the right. It's got the new bond to two methyls from acetone and a new bond to a new phenol that lost its aromaticity. Para position. And we have the original pi bond here and here. And the cation is here because we still have a hydrogen here. And that's going to make bisphenol A, which we have to draw because we need it for the next part of the mechanism. So bisphenol A is here. And how do we get there? Well, you made Cl minus again, way back when. You made it back here if you were keeping score. So it can reappear here where we need it a little closer to the action. Cl minus here. Grabs the H, sigma becomes pi, and you're done with that reaction. And I believe we're just doing a sulfonation next. H2SO4 and heat. Ortho to one of the hydroxyls is sulfonic acid. And I did that because I wanted to review the sulfonation mechanism. Not because this is going to be a plastic softener. This would be we're generating an acid here. We have to make that thing into this thing. So talk to me about all the things that need to happen there. Clearly one of the O's has to go. So we're going to need a proton around to make that happen. Provided by the same molecule. This is called fuming sulfuric acid when you heat sulfuric acid up. The acid is going to protonate another molecule of the same acid and the conjugate base, which is always present with sulfuric acid, will be used as a base to do what bases do. Take a proton. You could break it to two steps and show protonation of the O first, but we've been doing this so many times that one step is fine. It looks a lot like tautomerization, doesn't it? Really, this should have been protonation first, followed by this leaving, but I will accept it here as I do in tautomerization all at once. And this is the electrophile for sulfonation of benzene right here. It's got sulfur with 6 bonds to O, very positive sulfur. Pi electrons from the ortho position. Either these pi's here or these pi's here can be used. This one seems to be a little more, oh, it's a little tricky. It's a little tight in here. So there you're going to generate an O minus. We can do our R circle to save a little time. And that's going to generate R attached to an aromatic ring. That's not aromatic anymore. And what do we have? We have that. We have that. An OH in the ortho position, we have two things. We have an H. We have our new SO3 minus. Stable anion. I know some of you want to finish this off by using this SO3 minus and grabbing the H from another molecule. Works for me. Or you could realize sulfuric acid is present and protonation will be one step. And the conjugate base will do a deprotonation in a separate step. Probably the re-aromatization happens first. Because this thing really wants to get back to being aromatic, which means the acid base, in fact, the acid base involving a very weak base is going to be slow anyway, slower. And you make the product. Okay. And I got that. I did not have a chance to check my email to see if you had more questions. Did anybody send me anything? I can ask verbally. Did not open up my browser. We did not?
Yes, Professor, I sent you a question.
All right, well, we can catch up a little bit here by doing it this way. Save. Maybe my microphone's not on. That has happened before, and I think one of you was the ones that somebody was probably trying to talk to me. Now I can hear you. Yeah, I had my sound system off.
So I sent you a question.
Yeah,
for
you did?
mechanism for fall 2019, yeah.
It's from fall 2019. Okay, so I think this would be perfect to just take our break now, and I'll go get my email, get that document open, rather than you guys watch me do this. And I'll do that, and I'll be back with Fadia's question very shortly. And I think we're good, unless you're not. 3, 2, 1. I'll see you very soon.